Hello, it's Brian from Tavaran Games here with episode 4 of our strategy map generator tutorial series. So in this episode, I want to cover how I got the different terrain types to generate on the maps, where I've got these sort of snow tiles at the poles of the map, so the top and bottom, getting thinner and less snow as it goes further away from the poles, and then deserts generating in the center around what the equator would be, and then grassland between the equator and the poles on either side, with savanna sort of intermixed around that. And that was inspired by our real world, where deserts are more likely to form near the equator, and these grassland forested regions on our planet are more likely to be a little further north and south between the equator and the poles, and then you've got sort of polar tundra and grassland around that. Now, it is still dumb. It doesn't take into account ocean currents or mountain ranges or anything like that. It is pretty much randomly generated, but I think the effects end up being pretty good and should be fun for strategy games. Now, I had actually tried a different method of generating the terrain beforehand, and I'm going to show you how I did that because you might end up liking the results. I wasn't a big fan of how it turned out, but it's a simpler method that you can code very quickly and maybe you'll end up liking it. Okay, so let's go back to our tutorial, and last time we of course finished off by adding in these barriers on either side of the map that allowed the tiles to wrap as the camera moved, so you could have seamless camera movement in the horizontal direction. Now, one problem that creates that we didn't solve before is that if we open up the map, it looks fine. If we then move the map and hit the generate key, there's nothing there at first, and you might be going, what's going on? Well, if we look at the scene, all the tiles are over there because they generated underneath one of the barriers. The reason that that's happening is we're first moving and resizing those barriers, and then on the exact same frame, we're actually generating the map and the landmass. However, the actual new position of the barrier isn't taken into account until the start of the next frame. Now, this isn't a problem if you're in a game, if your player is just generating a map to play on because they're going to generate it, and they're going to immediately start playing. But while we're testing it, and we might want to generate map after map after map to see what different settings look like, we don't really want to be dealing with that. So all we have to do to fix that is after our camera movement in the generate function, let's close a bracket, and let's make a second generate function here, open that up, and then move this down, just make it look a little cleaner. And back in this first generate function, we're going to invoke the second generate function, generate 2, after one frame, so time.delta time. So that will give the program time to move the camera and register its new position, and then generate the land masses in. So let's save that. Let's go back to our tutorial, let that compile. Okay, turn that off, turn that back on. All right, we get our first landmass. Let's move the camera so that we know that they'd be under the barrier. Hit generate, and there you go. It works just fine. The camera moves, and then it generates the map. And it only adds one frame to the generate function, so it's very quick, and you won't even notice it. Okay, now that we've done that, I'm going to show you the old method of generating the terrain I first tried that I wasn't a big fan of. So if we go down here, when we're generating the masses, here we generate, this is where we put in the terrain type for the mass, and then we tell that mass to grow. So if we go over to hex type in the grow function, we're telling it again here to change to type 2. However, we can tell it to change to the type of mass that this hex is and save that. Going back here, we then can change this number to any number of terrain we want. In this case, let's do 1, 2, and 3, so our grasslands, our plains, and our deserts. The gray is meant to be mountains, and we're going to generate that separately, and the white is meant to be snow. And again, we're going to generate that in a different function. But okay, so we want to generate a value between 1 and 2, and that is fairly easy. So we're going to make an integer, type equal to 1 plus, we're going to round our value because we do want an integer, and we're going to do a random dot value times 2. So that will give us a value between 1 at the lowest and 3 at the highest. And then we're going to feed that into here. So save that, and let's run that and see how it looks. So same as always, let it compile, turn it off and on again, and boom, there we go. So you can see when we do that, we end up with these really big, chunky, weirdly distributed land masses, and the amount is kind of funky. Like, we only got these 3 grasslands, and maybe 4, and one of them's really small. These big deserts that all ended up sort of at the edges of the map, and then just a bunch of grassland in the middle. Now, we can try generating more land masses of smaller size. So let's say 2 to 4 on that, and generate those. And you can see it's a little better, but again, we have these large biomes that don't really interact, and there's not really any logic or reason to it. So I didn't really like that. I didn't like the way these maps turned out. However, if you do like that, and it's a method you want, well, that's a very easy method to do, and as you saw, it's just one extra line of code. However, we're not going to use that method. So let's turn this off, and let's go into here, and let's turn this type back to 2. And we're just going to generate an entire map of savanna as we did before, and then we're going to modify the land afterwards. So the way we're going to do that is through separate functions after we generate the masses. We want to call these in separate functions so that the land masses have all generated and all of these grow functions have all finished before we start to try to change the terrain. I found if we try to change the terrain in this generate function after this while loop, the grow functions won't have finished. So you only change these first few seed masses, but then this function is running along at the same time alongside this grow function, and you don't end up changing the masses you think you would. So we're going to make a new function, and we're going to make the snow first. Add snow. Oop. So for the snow, we want that at the poles. So top and bottom of the map is the way I have the poles. Now you can do this differently, but this will give you an idea of how to do it, and then you can change it as you see fit. So the first thing we're going to do is we're going to determine where the poles are. So we're going to make a new integer variable called ymax, and this will be the maximum height we want to go to. So we want the map size.y, and I'm going to use 10% on the top and bottom. And now that usually freaks out a bit. Always cast to an integer, always forget to do that at the start. But there we go. So this would be 10% at the bottom of the map and 10% at the top of the map. And although you see we're just at the bottom, we're going to get the top out of this as well. So we need to actually start our loops, similar to before where we've got an X loop and a Y loop here to generate the map. We're going to do pretty much the same thing. So we're going to go int x equal to 0, x less than map size dot x, x plus plus. So we're going to iterate through the x-axis. And then we're going to iterate the y-axis until y max. So y equals 0, y less than y max, and then y plus plus. Okay, so this is going to go through all the x values up from 0 to the y max point. And then we're going to work on those tiles, and then in the same loop, we're then going to take the top of the map from y max and work on it as well. So we first need to get our position as a vector2 position. So we've done this before, vector2 position, and we're going to set a new vector2, so the x, and then the y value, and we're just doing xy for now. Let's do our positional correction. As you know, with the hex grid, the y value needs to change and the x as well. So we already have this right here. So we're going to just copy that code. So this position.y, remainder 2 if it's equal to 0, move the x over by 0.5, and then correct the y value by multiplying it by 0.86. So copy and paste that, and we have our positional correction. Okay, let's do a quick raycast to that point to see if we hit anything, and we really should. We're within the map. So we want to raycast hit 2D. We're just going to call that hit, and this is a physics 2D raycast. And then we are going to put in our position. The direction doesn't matter because we're going to go with 0 distance, and we want the default masks. Nope. Mask, and then default. So we're going to hit a tile, and now let's make sure. So if we hit something, let's do something to it. So the first thing we want to check is, do we have a land tile there? So that's pretty easy. So we know we can check the hit types. So hit.collider.gameObject.getComponent. We can grab the hex type, and we're going to see if that is dot type is greater than 0. That will tell us it's land. Now I'm realizing we're going to be using this hex type more than once, so let's actually copy that and make that a thing. So we're going to make a new hex type. Wrong key. Hex type. Hex is equal to that. And now we can just go here and replace this with hex. That'll be a little easier. So we have greater than 0. But we also don't want to turn every tile equal to snow in that 10%. That would be a little bit boring. So we're going to randomize a little bit. So we're going to do a random.value. We're going to grab a random integer, and we're going to see if that value is less than or equal to 1 minus, so we'll cast as a float. Gotta bracket that. Watching me type very poorly. Float of the y value we're currently at divided by the maximum y value. So what's that going to do? Well, when we're at y equal to 0, this is going to be 0 divided by the 10%. So if the map's 40, that'll be 4. That's going to be 1 minus 0, and that's going to be 1. So when we're at the edge of the map, this is always going to be 0, and this is always going to be 1. So the random value is always going to be less than that. So every land tile right at the very edge of the map is going to turn into snow. Then, though, on the next y value, so this would be like 1, when it's 1, divided by 4, that'd be 0.25. So it'd be 1 minus 0.25. So the random.value is only going to trigger this statement 75% of the time. Y value gets to 2, 50%. Y value gets to 3, 25%. So what that's going to do is make it so that the land is going to get less and less snowy as it goes further into the map, further away from the edge. And then all we need to do is we need to set our tile. So hex.type is equal to 5 in the case of snow. So let's go back here again. So you can see our hex types. The white snow one is number 5. So we go back here. So we set it to 5, and then we just need to swap it. So swap type and put 5 in there. So that's going to change those tiles into snow. Now we need to go to the other side of the map. So we're going to basically copy this, but we're going to do a couple, or actually we can copy all of this. Let's move down. Now we need a new position, and this is going to be our top is going to be the map size.y minus y, and then we need to subtract 1 from that because we're generating to, when we generate the masses, that's up here, we go to less than map size.y. So we're going to 1 less than that because we start at 0. So in this case, though, when we're at y equal to 0 here, our map size.y minus y is going to be, in this case, say it's 20, when really we need that to be 19. So we got to subtract an extra 1. Okay, and then the same thing here. We do our x value correction, and then we do our y multiplication to make sure it's at the right height. We can get rid of this raycast hit declaration on our hit because we can just restate the hit here. And then, again, it's the exact same code. So right there, we're going to be modifying at the bottom of the map and at the top of the map, and it's going to loop through and add that. So let's invoke this in our generate function. So after we've generated the landmass, we're going to invoke this. So this is called add snow. And again, we're going to just wait 1 frame. Time.delta time. Okay, so let's see if that worked. Wait for this to compile. Hit play. Okay, let's zoom out, and there we go. We have some snow at the top and bottom of the map. Now, our map is only 20 tiles tall, so it's only going to go to 2 tiles in. And then by the 3rd tile, no more snow, because we chose 10%. So if we go back into our code and we say, instead of divided by 10, let's say divided by 5. If you want a lot of snow, maybe this is an apocalyptic nuclear war type map and you really want to put some more snow in, you can do that, and there you have a bit more. So you can play around with that to get the percentage of snow you like, but there you go. We have snow on the map. All right, the other land masses we're going to do in a very similar way. So before we go about adding our deserts, which we're going to do next, I want to go back to divided by 10 for our snow amount. The 5 was just a little more snow than I would like for now. And okay, let us add a function to add deserts. So we're actually going to copy our snow function because it has a lot of the elements we need. We're going to go here. We are going to change this to add deserts. We're going to invoke it at the end of our snow function. And again, same thing as before, time.delta time. Okay, so we don't need this second bit where we're looking at the other pole because we're just going to be going around the equator, around the center of the map. So instead of a y max, we're going to have a y minimum. And we're going to determine how far up we want to start the deserts. So let's make that 1/3 of the way up the map. So the map size divided by 3. Now we then need the top of the map, or the height up we're going to go. So we're going to call this the height, and we're going to make that the map size dot y as an integer, size dot y, and we're going to subtract 2 times the y min. Now the reason we're doing that is because if we have a map that's not divisible by 3, so say the map height's 20 as we have in the program right now, this y min will give you a value of 7 because it's going to round up. And then if we do 7, 7, 7, then the program's going to think it's 21 tall. Whereas what we would want is 7 on the bottom, 7 on the top, and then the 6 in the middle to become our desert. And this is how we're going to do that. And then we need to calculate the approximate center of the map, which in this case, because again we have rounding error, is not going to be right in the center. So we're going to take the height we have here divided by 2 and add to it the y min. And that's going to give us the approximate center value of where the desert should end up. Okay, so we're going to do the y min as where we start in the y. Our y max is going to be the map size dot y minus the y minimum. Okay. So, if y minimum is 7 out of 20, that's going to end up being 20 minus 7, which is 13, and that's the top we want to go to. So, we have our position calculations. That's exactly what we want. We have our raycast. That's great. And now what we need to change is our odds. So, in the snow, the further we got, or the closer we were to the edge, the more snow there was, and then the closer inland we got, the less there was. If we did that for the desert, though, we'd have a whole bunch of desert right at the bottom, towards the bottom up, and then it would just thin out going vertically, and that would look kind of weird. What we want instead is sort of an inverted parabola, where we have more desert along the center, and then as we get closer to the equator on each side, we have less desert being generated. So we need an inverted parabola where the odds are highest at the middle value and lowest at the extreme values, our y min and our height minus y min. Okay, so we can calculate that as a float, and we're going to just call that odds, and we're going to make that 1 over our parabolic equation. So we're then going to add 1, and then we're going to add the y we're at minus the offset. Oops. And then we're going to square that. So we're actually just going to take y minus offset twice, multiply them together. And then we're going to divide that value, not the one here, but the y minus offset squared, is going to be divided by the height we are traversing. And now we're going to cast that height as a float. The reason for that is if we don't do that, in C#, any equation where every number into it is an integer, it's going to export an integer. Which means this equation is going to just round down to 0. We're going to have 1 over 1 for everything, and our odds are always going to trigger. We're going to get desert across the whole area. If we make one of the values going into this division a float, and we can make it the top, one of these guys, or easier to make it this height value. And so we need to make sure that random value is less than our odds. Because when we're calculating these odds, if the y is equal to the offset, then this is going to become 0. This is going to be 1 over 1 plus 0. And so at the equator, where we are at our offset, it's going to be 1. As we get further away, as the y value becomes further from the offset, this number is going to increase. So this is going to be 1 over 1 plus an ever-increasing number the further from the center we get. So that this number overall, the odds, is going to get smaller, and we're going to get less desert as we get further away. We also need to change our type from 5 to 3. In the case of my lands, the deserts are 3. And we'll start it up. Okay, so it generates the desert. As you can see, it's a lot of desert right now. Again, because our odds, like at the center value at the offset, are 100%. We're going to end up with a lot. And that number's not getting hugely smaller. So we need to curtail that a bit. So let's go back to our code and let's add in a new variable we'll make it a public variable. So we're going to do a public float in this case, desert frequency. Let's do that. And then we're going to set that equal to 0.5f for now. And we're making it public so we can change it in the inspector till we get an amount we like. And then all we have to do is go back down to our adding deserts. And where we calculate the odds, we just need to have the desert frequency times this value we calculated. So that's going to be, whatever our desert frequency is going to be the amount of desert percentage-wise at the equator, and then it's going to offset and become lower and lower away from that. So we go back here, let this compile, and let's run that again. And we should have half as much desert. Okay, we have, very little desert. So 0.5 is a little bit low. Let's try 0.8. Generate that, and there we go. So we have, actually that looks like a pretty nice amount of desert. Now, we set this value to 0 in the desert frequency, we get no desert. We set it to 1, we get a ton of desert. So this is something that you would be able to change in the map editor, or that the players would be able to change, and we'll get to that in the future. In my UI, I have a desert frequency slider, and it'll change up the amount we generate. So there we go. I think 0.8 looks pretty good. I like that amount of desert. So we've done that. Now let's move to Grassland. So the Grassland is going to be basically a combination of the deserts and the snow, where we're going to look at, actually let's go back. So this area between where we generate the deserts and when we generate, so a band here, we're going to want to turn basically a parabolic curve like this of land into our grassland, and then same at the top in that gap there. So we're going to go back here. We're going to copy our, let's copy our snow script again because it's doing a lot of the heavy lifting. Oh, so we're going to copy it, not cut it. And then go down here, and let's rename this to add grass. We're going to invoke that. Time. Okay, so we invoked it. We can get rid of the invoke at the end of this. And now what we need to do is we first need to calculate our areas where we're going to generate our grassland. So we're going to go from a minimum to a maximum. So our minimum, we can set that to be where we ended up finishing the snow. We can go a little bit higher. We can maybe make that, say, 8. And so we're going to go from y to y min, from y equal my min. So this will be a little above where the snow finishes. And now let's set our maximum value. Again, we want, we're going to need to actually, round this one, because if we try to cast twin it, it's going to freak out. So we need the map size dot y, and if we divide that by 3 again, that'll be a third. So that will then go to sort of where the deserts finish generating. So that's our top value. Round to ints, otherwise it will be mad. There we go. So that's where we're going to end up as our maximum. We will also still need the height that we went. So in this case, our height is equal to y max minus y min. And then our offset, which we still need to get, is going to be equal to the height so halfway up. So height divided by 2 plus y min. So that's halfway between the y min and the y max. And again, this sort of takes care of all the rounding for us. Okay, so we have our odds calculation from before. We're going to copy that from our desert. We're going to stick this here. And again, this calculation is the same since we use the same variable names. And so we just need the odds. Now, right now we're using the desert frequency. We don't want that. We are going to want our new frequency. So we can go to the top, and after our desert frequency, a new public float, and we're going to call that grass frequency. We're going to set that equal to 0.5 as well. Actually, we liked 0.8 for the desert, so let's make those both 0.8 for now. Okay, so we go back down, we double check. So we're going to go from the y min to the y max. So that's from about 12% up the map to a third of the way up. And we're going to go, we're going to take the offset of the middle, and we're going to generate that parabolic curve in these odds. We need to change this to the grass frequency. Now I'm looking at, so not desert frequency for this. Otherwise, both values will be set from the same thing, and that is going to really limit us. Okay, so let's go back here to our map maker. Okay, press play. So the desert frequency, oh, quick little error there. We still have snow generating. The terrain type we need to go to is 1 instead of 5. Both spots here. Yeah. Let's, clicked on the wrong one. There we go. All right, quick little mistake. It's getting to be a long video, but there we go. We generated some grassland. Now, desert is 0.5 in the editor. Let's make that 0.8. So we can generate a decent amount of desert, a decent amount of grassland. We can generate, say, very little, lot of desert and very little grassland. Let's say 1 desert. Or we can generate a lot of grassland and no desert if we want. Stuff like that. So we have some options. But there we go. That is how I sort of figured out how to generate interesting terrains. Let's just change these up. And a way I really liked. Now, if you preferred the previous method I discussed, that's a lot simpler to code, of just starting with the blobs that generate and letting those spread into large biomes. However, I prefer this. It gives us a slightly more realistic map. So if we make that map a bit bigger, no, and more masses. We need more land masses if we generate a bigger map. I like this a lot better because it gives us sort of that more realistic value where we have deserts near the equator, grasslands, and what will eventually be forests closer to the poles, and then snow on the outside. So I think that looks pretty good and should work for most strategy games. That's all I'm going to cover in this video of how to generate terrain. In the next video, we'll go over how to generate mountain ranges. And then, if we have time in that video, also cover how to generate hills and forests and how I went about doing that. So anyway, if you got this far in the video, thank you for watching, and have a good one.